If Excel ever throws a value error and your whole sheet feels blocked, this is the fast way out. In most cases, value means Excel received the wrong type of input. Text where it expected a number, a range with the wrong shape, or a hidden character that breaks a calculation. The good news is you don't need to guess. You just need a simple checklist you can run in under a minute. First, confirm which part of the formula is failing, not just the final result. Second, check for text numbers, stray spaces, and non-printing characters. Confirm your ranges line up, same size, same direction. And fourth, handle errors intentionally so one bad cell doesn't poison the whole calculation. In this video, we'll focus on the 3 places value shows up most: sum, if, and VLOOKUP. You'll learn the exact causes, the quickest tests, and clean fixes that keep your workbook reliable. By the end, you'll treat value like a helpful clue, not a dead end. Next step. Let's build the mental model. Hash value is Excel saying, I can't interpret this input as a valid value for this operation. That's different from hash div0, which is a math issue, and different from hash NA, which is a missing match. With hash value, the usual culprits fall into 3 buckets. Bucket 1 is data type problems, numbers stored as text, dates stored as text, or a cell that looks blank but contains a space. Bucket 2 is shape problems. Your formula expects one cell but receives a range, or expects 2 ranges of equal size but they don't match. Bucket 3 is function-specific rules. Some functions refuse certain inputs, like text and numeric math, or an array result where a single value is required. When you troubleshoot, don't rewrite the whole formula. Instead, test pieces of it. Identify the first part that returns hash value. Once you find that first failing step, the fix is usually simple. Clean the input, convert the type, or align the ranges. Next step. Here's the quickest way to isolate the exact cause. Start by evaluating the formula in chunks. If it's long, temporarily copy it to another cell and replace parts with simpler references. For example, if you have sum if, or a VLOOKUP wrapped in math, test the VLOOKUP alone first. Next, check the inputs feeding the formula. Pick one suspect cell and ask 2 questions. Is it truly a number, and is it truly clean? A cell can look like 100, but actually be text, or contain a non-breaking space. Then, check for range consistency. If you're adding 2 ranges, they must be the same size, or Excel can throw hashmark value in many setups. Finally, confirm you're not accidentally passing a whole column where a single cell is expected. This happens a lot with functions nested inside other functions. The goal is to move from the formula is broken to this specific input is invalid. That's when fixes become fast and repeatable. Next step. Now let's hit the most common root cause, numbers stored as text. This is a classic hashtag value trigger in sum and any arithmetic, like A1 times B1. You'll see it when data comes from exports, copied systems, or pasted emails. The fix depends on what you need. If you want a quick conversion, use value on the cell, like value A1. If the issue is extra spaces, trim can help, but trim doesn't remove every hidden character. If you suspect non-printing characters, use clean or combine them, value trim clean A1. For percentages or currency symbols, you may need substitute first, like removing dollars or %H before value. Also watch out for dates. A date that's text can break calculations and comparisons. Converting it with date value can help. The key habit is simple. When math fails, confirm the inputs are numeric, not just formatted to look numeric. Next step. Let's talk about sum specifically, because sum can be deceptive. Sum ignores true blanks, but it doesn't magically fix bad inputs inside more complex expressions. If you do sum A1 to A10 and some cells contain text, sum often just skips them. But if you do something like sum A1 to A10 times B1 B10, or sum if, a single text value can trigger Nash value because Excel is doing element by element math. The fast fix is to ensure both ranges are numeric. If you must handle mixed data, wrap the risky part with if error, or force conversion with value. Another practical option is to use sum product, which is more tolerant in some scenarios, but it still can fail on text that can't be coerced. Also check for mismatched range sizes. If one range is A1 to A10 and the other is B1 to B9, you're inviting Nash value. With some problems, think range alignment and numeric coercion. Next step. If formulas can create Nash value in two main ways. First, the logical test compares incompatible types. For example, comparing a number to text that looks like a number can behave unpredictably, especially with greater than or less than checks. Second, the if returns a value that later breaks math. A common pattern is if condition, number, end. Then you try to sum the result. That empty string is text, not a blank, and in certain calculations it can trigger Nash value. A cleaner approach is to return 0 instead of end when you plan to do math, or return NA if you want to exclude it from some analyses. Another issue is combined with functions that can error, like VLOOKUP. If the lookup fails, the if might still evaluate a branch you didn't expect in older patterns. The safe habit is to keep outputs consistent. Numbers return numbers, text returns text, and handle errors at the point they occur. Next step. Here's a practical if example that causes headaches. You're calculating commission. You write if A2 equals yes, B2 times 0.1. It looks fine until you total the commissions and get Nash value in a more complex summary. The fix is simple. Decide what the no case should be. If you want it to contribute nothing to totals, return 0. If you want it to be visibly missing, return NA. Both are better than returning an empty string when you plan to do numeric work later. Another common if issue is hidden spaces in the condition. Yes is not the same as yes dot. Trim the input or standardize it upstream. Also be careful when your condition checks dates. A text date compared to a real date can fail silently or misclassify records. Convert the date first, then compare. With if, your goal is predictable types and predictable branches. Next step. Now, VLOOKUP. People expect VLOOKUP to return negative NA when it can't find a match. And that's true. But negative value happens when the function arguments are invalid. The biggest one is the column index number. If you use VLOOKUP, lookup value, table array, index num, false. And index num is 0, negative, or not a valid number, you can get negative value. Another cause is passing the wrong type into index num, like a blank cell or text. Also, table array must be a proper range. If you accidentally feed a non-range or a structured reference that resolves unexpectedly, you can trigger errors. And if you're building the index num dynamically with match, that match might return negative NA or an error that then surfaces as negative value in the outer formula. The fix is to validate each argument, confirm the index is a positive integer, confirm the table is correct, and test any nested match by itself. Next step. Let's make VLOOKUP more robust. If your column index comes from a header match, wrap it so it can't become invalid. For example, use match to find the header, but ensure it returns a number and handle missing headers early. Also, lock down the table array so it doesn't shift when copied. Another practical improvement is to trap errors at the lookup level, not after you do math with the result. If you do VLOOKUP times quantity and the lookup fails or returns text, the multiplication can throw hash value error. Instead, use if error around the VLOOKUP and decide what a safe fallback is, 0, NA, or a clear label. One more subtle issue. Sometimes the lookup returns a number stored as text. VLOOKUP will happily return that text, and then your math breaks. In that case, wrap the lookup result with value, so the pattern becomes value VLOOKUP times when you expect a number. That single change prevents a lot of downstream errors. Next step. A huge percentage of value errors come from invisible characters. The worst offenders are leading or trailing spaces, non-breaking spaces from web pages, and line breaks inside cells. These can break lookups, comparisons, and conversions. Trim removes regular spaces at the edges and reduces multiple internal spaces, but it does not remove non-breaking spaces. That's where substitute helps. Replace char 160 with a normal space, then trim. Clean removes many non-printing characters, like some line breaks. A practical cleanup formula for messy text is trim, clean, substitute A1 char 160. Once cleaned, you can safely compare strings, do VLOOKUP matches, or convert to numbers with value. The key is to clean at the boundary, right after import, rather than patching every downstream formula. If you standardize inputs early, hashtag value becomes rare, and your formulas get shorter and easier to trust. Next step, let's cover range mismatch errors, because they're sneaky. Anytime you do calculations across two ranges, like multiplying arrays, comparing lists, or using sum with array logic, Excel expects the ranges to align. If one range has 100 rows and the other has 99, you can get dash value. The same goes for mixing a vertical range with a horizontal one in certain formulas. The fix is boring but effective. Make your ranges explicit and consistent. If you're copying formulas down, lock the parts that should not move. If you're referencing entire columns, be cautious, because some functions behave differently with full column arrays. In older patterns, array formulas can be especially sensitive. A good habit is to define the dataset as a table and reference consistent columns, or use named ranges with clear boundaries. When dash value appears after a copy-paste, suspect that a range shifted and no longer matches its partner. Next step. Now error handling, because fixing dash value is good, but preventing it from spreading is better. The goal is not to hide problems, it's to control them. If error is the simplest tool, it lets you replace an error with a fallback, but use it carefully. If you wrap a whole complex formula in if error, you can mask real issues and make debugging harder later. A better approach is to wrap only the risky component, like the VLOOKUP, the conversion, or the division. Also choose fallbacks that make sense. Use 0 when you're aggregating totals. Use NA when you want charts and averages to ignore the value. Use a short label like check input when a human needs to repair data. This way, your workbook stays usable and you still preserve a signal that something needs attention. Controlled errors beat surprise errors every time. Next step. Let's wrap everything into a fast workflow you can reuse. When you hit number value, first isolate the first failing step by testing inner functions. Second, verify the data types, especially numbers stored as text and text dates. Third, clean inputs with trim, clean, and substitute for non-breaking spaces. Fourth, confirm your ranges match in size and orientation, especially in array-style calculations. Fifth, for if formulas, keep outputs consistent. Return numbers when you plan to do math. Sixth, for VLOOKUP, validate the column index and consider value wrapping numeric results. And finally, add targeted if error only where it protects the sheet without hiding the root cause. If you adopt this checklist, number values stops being random. It becomes diagnostic. One last thing. If you want, I can make a follow-up focused only on cleaning imported data, because that's where most of these issues start. For now, use the checklist, and you'll fix most value errors in minutes. Next step. Before you go, here's a quick way to self-check your formulas for the future. Anytime you import data, run a small validation column that confirms, is this numeric, and is this clean text? It's less work than debugging later. When you build formulas, decide early whether the output is meant to be numeric, text, or a deliberate missing value like NA. That one decision prevents most if-related hash value problems. And when you use lookups, treat the lookup result like raw input. Convert it if you'll do math with it. If this walkthrough helped, subscribe for more Excel troubleshooting guides that focus on practical, repeatable fixes. And for a quick comment, which function gives you hash value more often, sum or VLOOKUP? Small tweaks compound into massive performance gains. Subscribe to catch the next workflow optimization.